Hi, I'm Professor Mark Morris. I'm teaching at UCLA, where I also carry out my research. I work on the center of the galaxy and what's going on there in this fabulous arena there, and on dying stars, stars that have reached the end of their lifetimes and are putting on a display for us as they do so. Well, there's every expectation that in about 5 billion more years, our sun will swell up to become a red giant. And then as it gets larger and larger, it will eventually become what's called an asymptotic giant branch star, a star whose radius is just under the distance between the sun and the Earth, 1 astronomical unit in size. So the Earth will be literally skimming the surface of the red giant sun when it's an asymptotic giant branch star. A star that big is also cool. Red giants are red because they're cold. Red hot versus blue hot or yellow hot like our sun. Because it's cold, a red giant star at its surface layers can't keep all of its elements in the gas phase. So some of the heavier elements, the metals and the silicates, condense out as small dust grains. And when those dust grains condense out as solids, then radiation pressure from this very luminous red giant star pushes the dust grains out. That seems like a minor issue, but in fact, those dust grains carry the gas with them. And so the star literally expels its atmosphere and goes from a red giant star to a white dwarf when finally the core of the star is exposed. Now, as it's doing this, the hot core of the star is still very luminous, and it lights up through a fluorescent process, this outflowing envelope, this outflowing atmosphere that was once part of the star. And that is what produces these beautiful displays that are called planetary nebulae. Now, planetary nebulae can be these beautiful, round, spherical looking objects, or they can be bipolar. And that's one of the mysteries that we're working on here, is trying to understand why at some stage a star suddenly becomes axisymmetric. In other words, is sending out its atmosphere in 2 diametrically opposed directions predominantly, rather than continuing to lose mass spherically. We can't invoke rotation of the star. That would be one natural way to get an axis, a preferred axis, because stars don't rotate fast enough. If you take the sun and let it expand to become a red giant, then by the conservation of angular momentum, it literally won't be spinning at all. It'll be spinning so slowly that can't possibly have any effect. And so we can't invoke spin. So there must be something going on deep down inside the star that when you finally expose some rapidly spinning core, it can have an effect. Or all of the stars we see as planetary nebulae might have binary companions that could be very massive planets or relatively low mass stars that themselves impose an angular momentum orientation on the system. This is in fact an idea that I've been championing for decades now, and it has some traction. There's a lot of planetary nebula nuclei, the white dwarf, seem to have companions near them that are suspect as having been responsible for helping strip the atmosphere of the mass-losing red giant star, but also providing a preferred axis along which the ejected matter can flow.
Thanks for watching. Now make sure you click subscribe on our YouTube channel here. And maybe you still got some questions about space and astronomy, like this one, or that one. And if you don't see what you're looking for, then send me an email at info@universetoday.com.